If you've been following PHP's evolution over the years, then you've probably noticed that it's becoming increasingly expressive. We've got things like property hooks, attributes, read-only classes, and these aren't just syntactic sugar. They're reshaping how we think about building applications. Now enter Tempest, a PHP framework that takes these modern features seriously and build something genuinely different around them. Now, I've spent the last few weeks exploring Tempest, and what struck me isn't just its technical capabilities, but its philosophy. Where most frameworks impose structure through configuration and convention, Tempest discovers structure through intelligent code scanning. So let me walk you through what this means and why this matters. Traditional PHP frameworks require explicit registration of almost everything. Routes go in routes files, commands get registered in console kernels, services need providers. Tempest flips this model entirely with what it calls discovery. Let me show you a simple example that illustrates the difference here. So, let's say that we want to look at some routing. We don't want any explicit registration, and we want Tempest to scan our codebase during boot, finding classes with the root attributes, and automatically wire everything together. Let's have a look. Say we've got a PHP class, and we're going to put this in the namespace of app HTTP handlers, just to be different. We will want to use Tempest HTTP get and Tempest HTTP response. We can create a read-only class called book controller. Inside here, what we're going to do is have a public function show. You get the ID, and we are going to return that response. Now within here, we're going to say something like book equals, this is where we usually query it, so we're just going to kind of make this one up a little bit, because this isn't exactly how database interactions work. But return a new response using book to JSON, like that. Now, how can we get this to register as a root? Well, quite simply, we can just say get books ID. And that is it. That is all we need. Simpler, easier. And the same pattern applies to console commands, event listeners, and view components. And it might seem like magic, but it's actually pretty straightforward. Under the hood, Tempest uses PHP's reflection to scan your code base for specific attributes. It then builds its internal routing table or command registry and the service container based on what it finds. Let's move on to another interesting area, data mapping. Now, one area where Tempest really shines is in data transformation. If you've worked with APIs or complex data imports, then you know how tedious mapping between different formats can be. API A returns something like first name and last name, but what you want is actually just the combination of them to be name. Tempest Mapper component addresses this with kind of a more of an elegant functional approach. Let's take a look at this one. So we'd use function Tempest map. Now let's say we want to get basic object mapping. We can say user map. We get some user data from somewhere and we say to the user class. That's simple. We're just allowing it to map to a user. Now let's say it's a collection instead. So we want to get users. Okay, so we get the users array collection. We want to map every item in the collection to a specific user class. Quite simple. Now let's say we want to do some more custom transformations. Again, straight out of the box, we can say product is map some API data to a product class. But to do that, we're going to accept this callback, which is obviously an array. And within here, we're going to return a new product where the name is data name. Let's say that the price is something like money from cents data cost. And maybe a category is category from ID data category ID. And suddenly the way that we're working with this is super simple and super easy to work through. And Tempest handles this through, you can take this a step further by leveraging their custom mapping. So let's take the next example up. So let's say we've got a final read-only class for a customer. And what we've got is we've got a string for a name, string for an email, and we want to know when this user was registered. Now, this is our domain model. This is how we want to represent a customer with data. But it doesn't come to us that way all the time, does it? So we can use attributes and say map from, maybe it's customer name. And on email, maybe we're mapping from an email address. And maybe the registered at is actually coming through as registration date. We just don't know. So the beauty of the mapper functionality within Tempest, it just handles it for you. I found this pretty useful when integrating with third-party services where you have no real control over the data structures that they provide. The mapper also supports more of a strict mode for when you want to ensure that every property gets initialized, and you can build custom mappers for more complex scenarios. Everything integrates seamlessly with the framework's discovery system. Now, here's something that differentiates Tempest from more opinionated frameworks. It doesn't force any architectural decisions on you. If you want to use traditional MVC, great, go ahead. You prefer domain-driven design with hexagonal architecture, also great. Maybe you prefer ADR, the Action Domain Responder pattern, because you think it makes more sense. Go ahead and implement it. The framework just adapts to your choices rather than imposing its own. So let me show you what it might look like if we create a simple order processing implementation. So let's say this is our domain layer where our pure business logic lives. This would be under the namespace app domain orders, for example. So we'd have this final read-only class for an order. So we'd have this constructor, public function, construct. We'd have this private order ID of ID, private customer ID for the customer ID, and maybe we got this array of items. Relatively simple. Maybe we got this method on here, so we want to calculate the total, and we want to get a money object back, obviously. So we're going to return an array reduce on this items, where we're going to run over each one, total order item as item, and we're going to say total add item get subtotal, and then we're going to say money 0. Relatively straightforward. We got a nice little order class going on here. Now, what we've also got going on is we need our application layer, right? So we're going to have our application layer where we have all of our use cases. And we'll say that this namespace is applications, sorry. And within here, maybe we've got our order service. So we can have a read-only class for an order service. In our constructor, we're going to want to accept a couple of things. So we get that private order repository as orders, and then a payment service for payments. Within here, we want to process an order. We will get a process order command coming in, and we want to return an order. So our order would be something like this orders create using the command customer ID and command items. Then this payments charge, we want to charge based on the command payment method and the order calculate total. Then what we want is this orders save order and return the order itself. So there we go. We've got separation between our domain layer and our application layer. The next step is to kind of extract that infrastructure layer. So layer. So our infrastructure layer, which is our more frameworky concerns and how we're binding everything together. So let's say we've got this final read-only class order controller within here. And we want to public function construct a private order service for service. We're going to have this public function create. We're going to have this create order request as a request, and we'll return a response back. Now, this is going to be a post request to orders, for example. And we're going to say order is this service process order. And what we want to pass through to that is a new process order command using the request to array. Something like that. All hypothetical. So then we will return a new response using order to array. And that's it. We've split everything out. And notice how the framework concerns stay in the infrastructure layer while your business logic remains pure. Tempest discovers and wires everything together without requiring you to compromise your architectural vision. And if you want to smush everything together or use vertical slicers, or you want to use a modular architecture, it just doesn't care. It just lets you do what you need to do. So next up, let's talk about more complex workflows. So for applications with intricate business logic, a lot of the time in other frameworks, you struggle, you trip over things, and you have to kind of find workarounds. But Tempest includes a command bus that promotes clean separation of concerns. Commands are simple, immutable data structures representing intentions. Let's have a look. So we've got a final read-only class send welcome email. I'm going to say public function construct. We'll have a public string user ID and a public string email template. Straightforward, right? And let's see we got this other one. Final read-only class update user preferences. We have a public function construct. We've got this public string for the user ID, and we'll just have an array for preferences. Relatively straightforward, right? So handlers process these commands, and they're automatically discovered through attributes. So we can create a final read-only class for the email handler, which means we get this public function construct. And within here, we want to inject the mail service as mailer. And then we want to also pull in the user repository as users. Now, we've got this public function send welcome. And this is going to accept a send welcome email as a command, and it's not going to return anything. So the way that we get this to be registered is we just say command handler as an attribute. It's that simple. So we can say user is this user's find, and then we're going to get command user ID. And then we can say this mailer send command email template. Then along with that, we are going to say user email, for example. Straightforward sort of stuff. And dispatching commands is also relatively straightforward. So we can say this, once we've injected the command bus, we can say this bus dispatch a new send welcome email using the user ID and the welcome template. And the framework includes experimental async support for any background processing you might need to do, which it's particularly useful when you're kind of doing time-consuming operations like email processing, email sending, or anything where you might be interacting with a third-party service or service that is out of your control. Now, one thing that I really appreciate about Tempest is how it treats console commands. So instead of feeling like an afterthought that's bolted onto web controllers, console commands are first-class citizens with their own clean syntax. Let's have a look at how they work. Let's say we've got a final read-only class for importing users. Inside of our constructor, we could have a private user service for user service, and maybe we got this file processor for file processor. So they're invocable, so we can invoke, and when we invoke, we want to get a file name and a format with a default of CSV. And it's not going to return anything. So if this was standard code, we'd say, okay, so data is this file processor pass, and we'd say file name and format. Once we've got that data, we can say for each data as user data, we will say this user service create user, and we just pass through that user data. Then we'll say do something like echo imported. Maybe we count data users. Something relatively straightforward to do, right? But to get this as a console command, all we need to do is say console command. Now, how do we want this to be called? We want to call this import users. And then we're going to add this file name as a parameter so that we know we've got to pass it through. Now we're going to add this flag of format, and we can pass the default of CSV. And now we can just say Tempest import users, file name, and the format, maybe CSV, maybe JSON, maybe XLSX. It doesn't matter what it needs, but console commands are super simple to create. Now, the command definition includes arguments and option passing built in, and like everything else in Tempest, it is discovered automatically. Next up, I want to talk about one of the most what I'd call critical aspects of any framework: how it handles database interactions. And I think this is one of the reasons why a framework like Laravel did so well. It wrapped up that active record pattern in some very developer experience friendly syntax. Let's talk about Tempest though. And having worked with active record patterns and data mappers and various ORMs over the years, I was pretty curious to see how Tempest approaches this kind of fundamental challenge. And Tempest takes what I'd call more of a decoupled model approach. So unlike frameworks that tie your domain objects directly to database concerns, Tempest encourages you to keep your models clean and focused on business logic. So let's take an example of final read-only class user, something that we're going to have a lot. Inside of our constructor, we can have a public user ID for ID, string for a name. We can have an email address value object, and then a public date time created at. So we can do a public function is active, which will return a bool. And we can say return this email is verified and this created at diff in days now. Business logic-y things. Maybe we're going to have a public function get display name, which wants to return a string. We can say return this name, and maybe this is nullable, right? So we can say, okay, well in that case, get the email and get the local part. There we go, this email get local part. And notice what's missing here. There's no database specific methods, no magic properties, no inheritance from base model classes. It's a pure domain object that focuses entirely on the business logic. So how do we actually persist and retrieve these objects? And this is where they leverage repositories. So maybe we'll have an interface for the user repository where we've got a public function find. We get the user ID in there, and we're going to return perhaps a user. So our final read-only class for database user repository, which implements that user repository, is going to have a public function construct. We're going to get our constructor, and then we're going to have a private. We're going to get the database, and we're going to say this is the database. So when we implement this find using that user ID, and we want to return possibly a user, we will say user data is this database table user class, or we could say this database query our user class, where the ID is the ID to string, and we'll get the first one. Let's just tidy this up. And then what we've got after this is we can use a built-in mapper to say return if we have user data, then we want to map the user data to a user class or return null. It is that simple. The separation means that your business logic stays clean while your persistence logic remains more flexible. And if you want to switch from MySQL to Postgres, you just change the repository implementation. And if you want to add caching, wrap your repository in a caching decorator. Your domain model remains untouched. Now, the database query builder itself feels familiar if you've used Laravel's Eloquent, but with some maybe nice touches to it. Let's have a look at some examples here. So let's say we want to look at some simple queries. We can say that users is this DB. We can say table users where active is true. We want to order by created at descending. We want to limit to 10 and just get them. Feels very familiar, very similar to what we might usually do. So we can create some more maybe complex queries with joins, for example. So let's say we want to get orders. We can say this, let's say DB table orders And then we want to join the users table based on the orders.userid, where it is equal to the users.id. Might also want to join on some products, and we want to join that to orders product ID, which is equal to products.id. Relatively simple examples there. And we want to say where the order.status is status completed, for example, and then we want to select the orders.star, the users.name as username, and the products.title as product title. Then we can get it. And it's very expressive, it's very familiar. And for migrations, Tempest uses, again, a discovery-based approach. Migration classes get automatically discovered by implementing the database migration interface. And what I find refreshing about this approach is just how it encourages good architectural practices without being preachy about it. In practical terms, Tempest performs well. The discovery system adds minimal overhead since everything gets cached after that initial scan. And boot times in production are comparable to other modern frameworks, typically in the 15 to 25 millisecond range for moderately complex application. And more importantly, the developer experience really does feel streamlined. When I need to add a new feature, I can focus on the business logic first, and then add the minimal framework integrations that are required. There's no stopping to update configuration files or remembering any registration steps. And what I find Tempest works pretty well for is API-heavy applications with more complex data transformations, or projects where development speed is crucial. Maybe teams wanting to leverage more modern PHP features, and applications that require architectural flexibility. And the framework is still evolving, which means you're joining a community actively shaping its development. The Discord community provides excellent support, and the documentation covers most practical scenarios really well. If you're curious about modern PHP development, or maybe you're feeling constrained by existing framework choices, Tempest offers a really compelling alternative. It represents a thoughtful approach to framework design that respects both the language's evolution and your intelligence as a developer. The key insight behind Tempest is simple. Modern PHP is expressive enough that frameworks can discover structure rather than impose it. And whether this resonates with your development style is something you'll only know by trying it yourself. Let me know if you've given Tempest a try. What were your thoughts? Other than that, I'll catch you next time. See ya.